We're lucky enough to have two people from the Tropical Disease Institute. You guys want to introduce yourselves?
So I'm Claudia. I'm the coordinator for Caleb works with over the summer.
I'm Guillermo. I also work with the Tropical Disease Institute here. I've been working in Ecuador where Caleb was during the summer, like the past 2 years, and now I'm doing my master's degree here in International Development Studies.
Had to go to the World Cup. I don't know how familiar you guys are with Chagas disease. It's a neglected tropical disease.
I'm Mario Virhala, director of the Tropical Disease Institute at the Ohio University College of Osteopathic Medicine, and director of the Center for Infectious Disease Research. The Tropical Disease Research Project centers around Chagas disease. This disease affects between 8 and 10 million people in the Americas and between 200 and 300,000 people in Ecuador.
Each summer since 2001, a small army of international students and Ecuadorian professionals spend the season traveling to remote regions of Ecuador to combat the spread of Chagas disease. Trypanosoma cruzi, the parasite that causes Chagas disease, spreads via the chinchurro bug, a bug that is able to infect people while they sleep. But the disease does not strike right away. It takes decades after the parasite has entered the body before it begins to destroy internal organs, eventually causing a debilitating disease and often death in the prime of one's life to those who were infected as children.
Chagas is a silent disease. It's a disease that affects the poorest of the population in the developing countries of the Americas. This disease is extremely hard to diagnose and also is hard to treat. Therefore, it prefers to stay hidden.
Tropical Disease Institute, it started with much more of an entomological epidemiology, looking at Chagas disease and how they could stop this small bug. It's since then developed into more of a holistic development initiative, and I went down there with what is part of the Productive Initiative group, which is trying to spur economic development, but I was looking at sustainable agriculture and how to improve the profitability and also fertility of soils. Looked at a number of different things. Chagas disease on a graph here, the world's deadliest animals, right? You got your sharks, wolf, elephant, and then Chagas disease would be right about here. 10,000 deaths a year. Ebola would be right about here for this year. And humans evidently kill a lot more people than a lot of these diseases. And then below this, you'd have mosquitoes, malaria, about 750,000 people a year. As Dr. Grijalva's talks about in the video, it's a silent disease, and that you get affected, and then you won't see effects until you're 50 years old, and then you may have a heart attack while you're working in your field. So you can see how that could, hamper economic development, especially in communities where they depend on farming and whatnot. Getting sick in the middle in the prime of your life, obviously, is going to. Ecuador's found right here on the Pacific coast, next to Colombia. The Galapagos are right over here, and then these projects took place in the far south, up near the border of Peru. We took about a 14 to 17 hour bus ride to get down to where we were working. Beautiful curvy mountain roads. It was my first time in the southern hemisphere, so that was carrying along us all the way down here, and then we were working in 3 small villages. Here's a look at Oaxaca, which is this mountain right here. I woke up to that view pretty much every morning on the roof of the hostel that I was staying in, and it was a really wonderful place. People were very warm, friendly, and I really enjoyed the food. So just to touch on some of the stuff that the Healthy Living Initiative works on, and in terms of the research that I was helping with down there, just looking at, as the whole system in a holistic way. So here, on the right, the format is a little strange because I had it on widescreen here, but here you can look at these different living conditions. These chinchorro bugs, they thrive in areas where people live in somewhat, substandard conditions. They have cracks and they live in a mud hut and they have cracks in their walls, and the bugs can thrive. They have lots of places to hide. It's not these clean, sterile environments. A chinchorro bug could not thrive in this environment because we'd be able to see it, but they can't see them, and then they get infected. And then that in turn affects their production, and then they don't get as much of a yield of their corn. They don't get to go to market. Then they don't get money, so they can't improve their house. And then they can't end up with a nice, this is a community house that TDI and Healthy Living Initiative has worked on. It's pretty much a prototype house that is Chagas proof, or basically chinchorro bug proof. This is a picture of a class of graduate assistants who took the class in the spring, and pretty much January to May was a lot of project formulation, a lot of reformulation, and then you go reformulate again. But it just really made me appreciate how much planning goes into, a 3-week project, because even, regardless of all the planning that we did, there were still things that came up, and you have to adjust. We were interviewing farmers. I don't speak Spanish, so I was working with a Colombian graduate assistant who's in the ComDev program, and she was actually conducting the interviews. I have some background in water treatment. When I was in the Peace Corps in West Africa, I had a couple visits to water treatment systems in some of these affected communities, and that was really interesting, and hopefully we gave some good suggestions as well to how they could improve those. This is what we did with some of the farmers, and free piece of pizza to anyone who can identify that right there. Yeah, cassava. Yeah. So cassava, corn, plantains, that kind of stuff is their main staple crops, and we would go and we'd interview these really warm, friendly farmers about their agricultural techniques, how they combat pests naturally, how they fertilize naturally. These farmers are really kind of on the front lines of the cross-section, I should say, between sustainability and agrochemical companies. A lot of people have gone down there and tried to, I think you can attest to this too. There was a big push for chemical fertilizers down there, and a lot of the farmers have responded by saying, that doesn't make us more economically independent. In fact, that hurts us. They have such a wealth of knowledge of how to restore the earth naturally. A very low percentage of them use any kind of chemical fertilizers, even use pesticides, even though they identified that as one of their main problems. A lot of interviews, a lot of visits. The days were nothing short of exhausting. We were waking up at 5:30, leave town, drive 2 hours, go work in the valley until about 5 p.m. and then drive back out. So you're doing 12-hour days, 6 days a week. Here's just a rudimentary sketch here on the left of what I was doing when we were looking at the water treatment systems. They go up into the headwaters, up high on the mountains, and they capture a stream, and then they filter that through down the mountains to the communities. And in this particular treatment system, an NGO had provided, and they got their funds for it, but they were having problems with it with sedimentation. So these tanks would get full of sediment, and particularly bacterial quality. So we went up, I hiked several kilometers with a few people and a mechanical engineer, and we looked at the stream capture system. And this is basically where their water is coming from. It comes out of the stream bed, filters through a grate, and then goes into a sediment capture tank, which I'll show you guys, and then is piped down several kilometers to the other treatment system. But they're having to do constant maintenance on this, and in a sense, it kind of reminded me of some projects I saw when I was in the Peace Corps, in that this NGO came down and they spent some money and worked with the community and put in a great water treatment system at the bottom close to the community, but didn't address this problem higher up in the line, which is a pretty simple fix really, just to get sediment out of the line. They didn't address that. So the affected communities are having to constantly shut the system down, flush it, spend lots of money to do upkeep, when they really could spend around $1,000 and fix the system to make it work more efficiently. So here's just a look at some of the stuff that we were doing, making recommendations on these treatment systems. This is the sedimentation tank. It obviously wasn't working. It's supposed to be kind of sequential stair steps, so that the water's losing momentum, sediment's dropping out. But this is what the water was looking like. So if you get that much sediment in the line over kilometers, you have to flush it constantly, lots of maintenance. I had a really good time. I loved Ecuador. I definitely would like to go back. I got to help make some cane liquor moonshine, which was pretty cool, with Don Fernando. That was a great day. We're doing a sugarcane press there. It was absolutely beautiful there. And also another thing that really touched me from the Tropical Disease Institute was just the diversity of people I was working with. We had Pakistanis, Saudi Arabia, Colombian, Dominica, Jamaica, and then a number of American students as well. They spray the houses. It's not obligatory, but the government of Ecuador is also very engaged in going to these houses and eliminating the bugs. But the problem is that you can spray, but they'll come back.
If you use that, they're going to prevent bugs from coming to the house for 6 months. After that, they're going to come back. So if you do not improve, the conditions of life, if you do not improve the house, you do not generate more income generation opportunities, if you do not create sustainable agricultural systems, etc., the bugs are going to keep coming. It's a structural issue.
It's in a very remote area. Control the bugs, or you can improve the house. There's an active way and there's a passive way.
My thesis research looking at the species Agave americana, this plant as a potential bioenergy feedstock, as well as its relative impact upon the surrounding wildlife. A little bit of background about why I became interested in this topic in the first place, largely due to the fact that energy reform has been gaining momentum in our scientific and global society. It's arguably the largest driving factor due to the rapid depletion of non-renewable resources, the search for more efficient and productive alternatives, increased desire for energy independence, and of course, the oncoming issue of climate change, largely due to the historical burning of fossil fuels. However, alternative energy cropping systems have the capability to displace these fossil fuels due to their ability to sequester carbon both above and below ground in their biomass. And obviously this benefits the environment. However, there's been a lot of common misconceptions that have been implied upon the bioenergy industry. A lot of this comes from the excessive burning of corn ethanol and its production. It's been criticized as costly and detrimental to the environment. The excessive production of intensively managed corn, the leading crop in the United States, and about this is currently attributed to the burning and production of corn ethanol. Currently, over 90% of consumptive water use goes towards agriculture in the most locally water-scarce regions. They might have greater net productivity as a bioenergy crop than other bioenergy feedstocks previously investigated due to the fact that they are exceptionally productive. Since they are native to these arid and semi-arid regions, they can be grown in these regions, and these regions usually have a lot of marginal or abandoned agricultural land, so these crops actually do well to be placed on abandoned lands where they don't require high soil fertility. They're also highly efficient structurally. They have high levels of soluble carbohydrates and low levels of lignin, which basically translates to the facilitated conversion of biomass to liquid fuel. These plants have their stomata open during the nighttime, and that way they're exchanging gas during the cooler nighttime hours, and then they close during the day so that they're especially water use efficient in these arid regions, since they don't risk losing water to the heat of the desert sun. How does wildlife impact kind of tie into all of this? Many different factors that must be taken into account when selecting a sustainable bioenergy feedstock. It's talking about the bioenergy feedstock that will be the least detrimental to the environment. I decided to look at the impact on wildlife, and this is a picture of a female tail lizard. Pinal County, where in the city of Maricopa lies in south central Arizona, has over 50 reported species of amphibians and reptiles. Despite the fact that reptiles in particular are among the most abundant classes of land-dwelling vertebrates in the region, their response to development is among the least understood. This is especially worrying due to the fact that reptiles have exceptional ecological constraints. Their ability to disperse or be mobile is limited due to their habitats in these desert regions. Not only is negative wildlife impact detrimental to the environment, it's detrimental to the success of a bioenergy system, upon which the success of this system depends on the healthy ecosystem. There's increasing evidence that biodiversity might be just as important for ecosystem functioning as other biotic factors within an environment. And this is due to a dynamic relationship between species diversity and ecosystem productivity. So my study and why I was out in Maricopa this summer was to examine how different irrigation treatments might affect agave americana biomass and thus its potential biofuel productivity if it were to be incorporated into the bioenergy industry, to determine whether irrigation is required at all to produce the commercially viable yield of agave americana in this region, and to monitor and compare the abundance, richness, and diversity of the wildlife, particularly herpetofauna, or amphibians and reptiles, in 3 different sites, in an agave site, a conventional agricultural site, and a native site. I was in Maricopa, which is just south of Phoenix, Arizona, from June through August of this past summer. 4 different irrigation treatments at the agave site, and that has to do with the potential biofuel productivity and measuring that aspect. And then the native site and the cotton site were both used to evaluate the wildlife impact. Dr. Sarah Davis, my advisor, in 2012, she established the agave site, and it is subdivided into replicated plots. So there's 2 of each of these 4 different treatment plots. There's control, which is rainfall only, no applied irrigation, 200 millimeters a year, 400 and 800. Using a LIFOR portable photosynthesis system, which is this machine right here, we use that to measure the physiological response to the different irrigation treatments. And this records the photosynthetic rates, and although plants are not technically photosynthesizing in the absence of sunlight, they are respiring. So the photosynthetic rates that are read off of the machine give an idea about the carbon assimilated overnight. So these are typically taken over a 15-hour period throughout the night. So this is the part where Nick is very gracious in being out all night. We are going out again, actually, in like a couple of weeks to get another set of measurements. Because we want to get readings from 3 different parts of the growing season. So we got readings in March, June, and now we're going to get one in early November. So this will be used to assess the patterns in carbon assimilation between the treatments. And then biomass subsamples are harvested as well. And this gives an idea of the differences in biomass, estimated yield, and the water use efficiency between the different irrigation treatments. The good news is, in this region, especially in the summer, nighttime is when you want to be outside. You don't want to be out doing field work during the day. Lucky me, I chose a project where I had to be out both times. In terms of wildlife impact, I installed 3 pitfall arrays. This diagram here is called an array. At each of the 3 sites, 3 at the agave, 3 at the native site, and 3 at the cotton. And it consists of 4 pitfall traps, which is A here, and those are just 5-gallon buckets flush with the ground that are perforated at the bottom, so if any liquid gets in, we don't try and minimize the casualties if an animal gets obviously captured in there. I checked the traps at each site twice a day, and I identified, recorded, marked the species for recapture, then released them. So I marked them for recapture just with like a dot or stripe of white out on their back. It was actually the most effective, and it turns out it doesn't rain a lot in Arizona, so we don't really have to worry about it washing off. And I'm going to use this data to assess differences in species richness, diversity, and abundance. When you're out there in the middle of the night or in the middle of the day installing these traps, you're like, I really hope I catch something. So like the first time I caught an animal, I was like, these work, oh my gosh, and they work very well. So here's a picture of the 3 sites. This is the trap installed at the agave site. This is just a picture of the cotton site, so you get an idea of the environment and the landscape there. These that were caught in the agave site, and the species also overlap, but I just wanted to give you an idea of the different specimen that I got in my traps this summer. So these are all found at the agave site. I was there during monsoon season, so it rained a few times. This is a round-tailed ground squirrel. A lot of people there call them prairie dogs, but they're all over, and they're actually kind of a pest to the agave because they eat the roots. And then this is a sonoran desert toad. This is at night with my headlamp. So these big toads, they're found in all 3 of the land uses, which is good because I believe they're endangered. They're under endangered in the state. In the native site, this is a giant desert hairy scorpion, 3 of those, and I had snake tongs. This is a desert spiny lizard. This is a gopher snake. The native site was also a bed and breakfast that we can see. This is the zebra tail lizard, male, really pretty. I thought this was great because it's a desert spiny lizard on top of a Sonora desert toad, and I found them like that. I didn't catch any snakes. A zebra-tailed lizard with a quail. I had a lot of limitations to time and money. I observed juvenile diamondback at the native site. I got quite a few of these western banded geckos, really pretty animals, and This is a kangaroo rat. He's all wet because he exhausted, and so I poured water out. At 7 in July, it's already like 95 degrees. This is an adult tiger whiptail. Really, really fast lizards that run close to the ground, and there's a ton of those in the native site. And then last but not least, this is a desert iguana, and I'm not really sure if this picture does it justice, but that was by far the largest specimen I caught this summer. Lastly, these are some animals at the cotton site. So this is a cactus mouse, which is just adorable. It looks like a hamster. And this is a juvenile tiger whiptail with a pretty blue tail and striping. This is a woodhouse's toad, and just for reference, this is the top of my boot. So it was really, really tiny. Lots of black widows in the agricultural stand. This is the raw data between the 3 sites. So there were 7 different species in the agave with 30 captures and 2 recaptures. The native actually only had 9 different species. It seemed like a lot more because I had 77 captures there, but 10 of them were recaptures. And in the cotton I had 10 different species, but only 20 captures with 4 recaptures. So far our lowest estimated yield was about 3 micrograms per hectare, with a water use efficiency ranging from about 8 to 6 kilograms per hectare per millimeter. And the takeaway from this, when comparing to conventional crops in the same region, the estimated yield and the water use efficiency of all of the agave treatments was about 7 to 8 times greater than that of conventional crops in Arizona. Cotton to create a yield of 1.46 micrograms per hectare, it required over 1,000 millimeters a year of irrigation, which is obviously more than our highest irrigation treatment for the agave. Based off of my instigated research and my preliminary results, it's that irrigation might not be necessary to produce a commercially viable yield of agave in this region. Both the agave and I'm fairly certain that the cotton are fertilized, but a lot more fertilizer and irrigation obviously goes into the cotton. Definitely a lot more intensively managed. You can grow a lot of things in the desert actually. It's just the issue of how much water is required or how much fertilizer.
I have bottles of agave sweetener at home. So is it the high sugar that makes it a good biomass?
Mm-hmm.
And it's actually thrown into furnaces and just burned to make energy?
Yes, there's a lot of experiments and different processes that go with the downstream process of converting the biomass to biofuel. But the high glucose content is something that makes it, these sugars are readily available to be fermented into ethanol. So that's why it's used to make alcohol, it's used to make a syrup. Ours is the first looking at agave as potential biofuel in the United States. It's been investigated obviously as a food source, as an alcohol source, as a fiber source.
Yeah, my name is Henry. My work is on the influence of the water quality and sediment transport and also mine village research. Looking at the recovery, the biological recovery downstream of lime dozers in relation to the chemical recovery as have been seen over the years. This is Job's Hollow, Pine Run. The objective of my study is to investigate the factors that contribute to biological recovery. My specific objectives are to explore the differences between the recoveries in these watersheds. I also have a look at aqueous water chemistry in relation to the biological recovery, and also to see the influence of sedimentation and to see how they also boost up work of the lime dozers. Total duration 12 months. We're looking at 8 to 11 miles downstream of the lime dozer systems. Water quality and then sediment chemistry and grain size. So my steady watersheds, and I've drawn it up over there. So you have Monday Creek. This is Monday Creek, West Branch of Sunday Creek, and this is also within Raccoon Creek, which is far bigger than that. And then this is Thomas Fork, which is also within Leading Creek, which is far bigger than that. But this is just the watershed. And so these are my sampling points on the streams. The brown spot is the dozer location, so I'm doing all the sampling downstream of the dozer systems. But some of them are sampled just above the dozer to see the relationship. And so Thomas Fork, especially, I do that. I always measure up above the stream, above the dozer location, and then I relate that to the downstream locations. Yeah, that is West Branch 2. And we had a class trip with Dr. James Viteto, seed saving and of heirloom apples. It's a lot of nature and the various indigenous Ohio seeds and plants that we can find all around us, which are also disappearing. This is Tent City. Then we took a lot of hikes in Silo, which is up in North Carolina. So this is a quartz mine. That is John Straw. This is another one of the indigenous plants. This is up on the Mount First hike that we had.
Mountain Gardens?
Yes, he has a lot of plants from all over the world, produces these plants for very exquisite restaurants from all over the world. People come all over the world to come and buy his stuff. Yeah, this is the nightlife. Every night is the campfire. That was her first time climbing a tree. That is Dr. James Potato treating us to a solo. The poems and the songs were all about the various trees and the environmental destruction and all, the relationship between all that. That is us saying goodbye. So we went to Oklahoma City for a conference. That's me in a selfie in a big this bar had
We were at an early career social event. They fed me.
Yeah. I did some work with the Watershed Partnership because that is me with Jane. I don't have a lot of results now. I have a lot of results, but
Yes, he has way too much data and he's trying to figure it all out now.
Nice outfit, Henry.
This was not this summer.
no, this is not the song. This is.
This is everyone's favorite photo. We put it in almost every single presentation we do now.
A Ghanaian trying to stay warm, trying to acclimate.
That's like, I mean, like 5 layers of clothing up there.
Photographer, what's your name?
Daniel Winters.
Oh, go on.
Oh. I just moved back to Ohio. I've lived in New York for the past 5 years. Yeah, it's a relief. I'm friends with a bunch of people that work here. I said I'd like to do a show, and they said, well, how about this time? And I said, that sounds great. This is the show.
Sure. The little animals over there, that's my work. I'm Brady Hashman, and I like to torch things.
crab, I guess is what they call it.
What's the name of this piece?
I do not know.
Snowy? Is that her name, Winter and Summer?
Yep.
Woo! Woo!
Come here. Hey, stop. Don't be a grump.